In this lecture, we'll be exploring the arithmetic operation in Python. They are pretty simple. Let's get started. We use the plus sign for addition, minus sign for subtraction, and asterisk for multiplication. For the division, we have two types of operators. A single slash is used for float division and always returns a float. Double slash is used for integer division and always returns an integer. If the result of an integer division is a float, then the decimal part is truncated to make it an integer. We also have a modular operator, which returns the remainder of the division. Here are some examples of arithmetic operations in Python. Print, open bracket, 5 plus 3, close bracket. Print, open bracket, 6.5 minus 2, close bracket. Print, open bracket, 2 times 4, close bracket. Ready for a small quiz? Answer the following questions. What is the correct output of the float division between 4 and 2? Remember, the result has to be a float. What is the correct output of the integer division between 4 and 2? Remember, the result has to be an integer. What is the correct output of 9 divided by 2? Here are the correct answers. How many did you get right? Comparison operators are used to compare two values. They return either true or false depending upon the comparison. Here is a list of comparison operators in Python. Greater than, forward arrow, less than, reverse arrow, greater than or equal to, forward arrow, equals, less than or equal to, reverse arrow, equals, not equal to, exclamation mark, equals, is equal to, equal sign, and that's it pretty much. Now on to the next lecture. Next up is logical operators. Logical operators are used to combine two or more conditions. There are three logical operators in Python: and, or, and not. Let's go through each one of these. An operator returns true only if all of the conditions are true. Otherwise, it returns false. Let's have a look at an example. In this demo, we'll be looking at the AND operator. Let's go ahead and type print. In this case, the first condition is true, but the second condition is false. So AND should return a false. Let's go ahead and run this cell to confirm. And yes, it does say false. Now on to the OR operator. The OR operator returns a true if at least one of the conditions is true. It returns a false only if all of the conditions are false. Let's have a look at an example. In this demo, we'll be looking at the OR operator. Let's go ahead and type print. In this case, the first condition is true and the second condition is false. So OR should return true. Let's run this cell to confirm. And here you go, it says true. Now on to NOT operator. NOT is a unary operator, meaning that it takes only one operand. It reverses a true to false and false to true. Let's do an example of NOT operator in Jupyter Notebook. In this demo, we'll see how NOT operator works. In this cell, let's type x equals true, print x, print not x. Our variable is x is set to true, so print x should print true on screen. Print not x should print the opposite of x on screen, which is false. Let's run this cell to see. Select the cell and run it, and we see true and then false on screen. Okay, so quick questions. Predict the output of each of these comparisons operators. In this lecture, we'll talk about conditional statements in Python. There are three conditionals: if, else, and elif. We start with if, followed by an elif, which is followed by an else. Both elif and else are optional. The conditions are evaluated in a top-down manner. If the if condition is true, its block is executed and the rest of the elif and else are skipped. If the if condition is false, first elif condition is checked. If it is true, its block is executed and all the other elif and else are skipped, and so on. If none of the if and elif is true, only the else block is executed. Let's have a look at conditional statements in Jupyter Notebook. Let's create a small program using conditional statements. We say if 5 equals 6, print bracket 1 close bracket, elif 6 equals 6, print bracket 2 bracket, else print bracket 3 bracket, close full brackets. Since the first if conditions is false, it checks the first elif condition. Since this is true, it prints 2 on screen and skips the else block. We can also combine conditions using the logical operators that we discussed earlier. Just see how we're combining conditions in this piece of code using the AND operator. And now on to the next lecture. Loops in Python are much more intuitive than any other language. We have two types of loops: for loop and while loop. For loop takes a range function which takes 3 arguments: start value, end value, and step value. The for loop begins at start value. However, it runs until end value minus 1. This is because the end value is exclusive. After every iteration, the iterator is incremented by step value. Let's create a function that prints all the even numbers from 0 to 20. So, we say the following. Since we want to begin at 0 and go until 20, we would give the start value of 0 and the end value of 21. Because it's exclusive, and every even number is 2 steps away from the next one, so we give it to a step value of 2. Let's convert our thoughts into code. For I in range bracket 0-21-2 close bracket, print bracket I close bracket. Let's run this cell, and here you go. We have the desired output. In the range function, if we omit the step value, it is set to 1 by default. The following code prints all numbers from 0 to 20 because the step value is 1. Now on to the while loop. A while loop takes condition and runs as long as the condition is true. Let's try it in Jupyter Notebook. We create a variable I and set it to 1. I equals 1. Then we create a while loop that runs as long as print bracket I close bracket, and then finally we increment the value of I instead of the while loop. I equals I plus 1. Let's run this cell and see the output. It prints all the numbers from 1 to 10, and as soon as I becomes greater than 10, the loop stops. We can also create an infinite loop that keeps running forever. We normally have a terminating condition that, when true, terminates the infinite loop. We use the break keyword to terminate a while loop. To create an infinite while loop, we say while true. Inside of this loop, let's take an input from the user, their username. If the user enters, let's say James, we print a welcome message and break out of the loop. Username equals input bracket enter your username close bracket. If username equals James, print bracket welcome James close bracket, break. In all other cases, we display a wrong username message and the loop continues. So we use an else block. Else print bracket wrong username close bracket, Alright, now on to the next lecture. So we discussed primitive data types in Python. In this lesson, we will discuss the non-primitive built-in data types in Python, also called sequences. A sequence is an ordered collection of objects. We are going to look at lists, dictionaries, and tuples. Len functions is used to find the total number of elements in any sequence. We will start our discussion on sequences with lists. A list is used to store multiple values which may or may not be of the same data type. Lists are multiple, i.e. once created, they can be modified. To get a particular element from the list, we use indexing. Consider the given list containing 3 elements. Let's call this list flower list. To get the element at position 0 or the first element, we say flower lists bracket 0 close bracket. Similarly, to get the second element or element at position 1, we say flower list bracket 1 close bracket. And for the last element, we say flower list bracket 2 close bracket, because it is at position 2. List slicing is used to get a portion from the list. We give a start index which is inclusive and an end index which is exclusive. We get all the elements from the starting index to end index, -1. Let's actually see list indexing and slicing in action. Flower list equals bracket rose dash lily dash tulip close brackets. Let's get the first element from the list using indexing. First element equals flower list bracket 0 bracket print. Now let's get the last 2 elements from the list using slicing. We put a colon between start index and the end index. Bracket last 2 elements equals flower lists bracket 1 3 bracket close print last 2 elements. We can run this cell and we see the output is as we had expected. we can iterate over a list using a modified form of from loop. To iterate over a list, instead of using the range function in the for loop, we give the name of the list. So we do something like this. For I in flower list, print I close brackets. We run this cell and it prints all the elements in the list on the screen. And now on to the next lecture. Dictionaries are used to store key value pairs. Dictionaries are also multiple, just like lists. In the given figure, we have a dictionary called Grade Dictionary, which has 3 key value pairs. The first key is in English, value associated with which is A. The second key is maths, and the value associated with it is B. Similarly, the last key is history with the value C. We can use the key function to get all the keys in the dictionary and the values function to get all the values in the dictionary. To get a value associated with a particular key, we pass the key inside of the square brackets instead of the index. Let's move to Jupyter Notebook to see things in action. We create a dictionary called data. Data equals name, James, age, 30, country, US, close brackets. The keys in this dictionary are name, age, and country. The values associated with them are James, 30, and US. Respectively, let's get the values associated with each key using Python. Name equals data, name, age equals data and age, country equals data and country. Print name, print age, print country. Let's run this cell. Okay, so we have the values associated with the keys. Please note that we can iterate over a dictionary to get the key value pairs in it using a modified form for loop. Let's look at it now. So we create our data dictionary again. Data equals name, James, age, 30, country, US, close brackets. Then we do something similar to the for loop that we used to iterate over a list. For key in data, print data key, close all brackets. And here we have the output. Now on to the next lecture. Tuple is used to store multiple values just as a list. The only difference between a tuple and list is that a tuple is immutable, which means that once started or created, a tuple cannot be modified. We can index a tuple in the same way we index a list. We can slice a tuple in the same way we slice a list. Here are some examples related to tuple indexing and slicing that you can look at. We can iterate over a tuple the same way we can iterate over a list. In our code here, we have the following tuple. Flower tuple equals bracket rose, lily, close bracket. And then we iterate over this tuple using the for loop. For item in flower tuple, print bracket item, close bracket. And then we have our output. Now on to the next lecture. Python has a lot of built-in functions, such as the len function, the ab function, the max function, and many more. Inside the PowerPoint presentation, you can click on the given link to find a detailed list of these built-in functions in Python. And now on to the next lecture. Apart from the built-in functions, we can also create our own functions in Python. These are called user-defined functions. Noted that in Python, a function should be defined before it is called, otherwise function call will throw an error. In this lesson, we will be going over functions in Python. First of all, to create a function, we use the keyword def and then we give our function a name. Def add numbers, close bracket. We provide parameters inside of the parent these and put a colon. Def add numbers, bracket x, y, close bracket, sum equals x plus y. And then finally, we return to the volume of sum. Return sum. Let's create another cell and call this function. Result equals add numbers, bracket 5, 7, close bracket, print, bracket, result, bracket. So here we created a variable called result. We then assign it to the value of add numbers 5 and 7. And then we printed the variable result. Let's run both of the cells and see the output. So we see 12 on screen, which indeed is the sum of 5 and 7. That is the value of the variable result. We can also return more than one value from a function. When returning values, just separate values from each other using a comma and create another variables in function call. Let's have a look at how it works in Jupyter Notebook. Let's go ahead and create a function called increments by 1, which will take two parameters, increment each one of them by 1, and return the updated values of both of their variables. Let's write the code. Def increment by 1, x and y, x equals x plus 1, y equals y plus 1, return xy, close all brackets. You see we are returning both x and y from this function. Now let's go ahead and call this function. Since the function returns two values, we need to create two variables to store each of the returned value. num1, num2 equals increments by 1, 5, 7. Print num1, print num2. So our first value returned from the function will be stored in num1 and our second return value will be stored in num2. We can return as many values from function as we want. Welcome to the second section of this course. In this section, we will be going briefly over the Python libraries that will be used throughout this course. Remember that we have separate modules for each of these libraries where we will be discussing them in detail. Let's begin. As discussed in Chapter 1, installing Anaconda installs all the essential Python libraries for data science. So, for now, we do not need to install anything. Installing a library is not enough. We have to link it to every problem that we want to use it in. This linking is done through the import keyword in Python. We can also use the optional as keyword to use an abbreviation for our libraries. This way, instead of typing the complete library name every time to use the library, we only type the abbreviation, reducing our syntax. Let's go ahead and import our libraries. So, we have our Jupyter Notebook opened up. As said earlier, Anaconda installed all the libraries that we will be using in this course. We just need to import them. So we say import pandas as PD. So, PD is the abbreviation that we will be using to call pandas library. Let's import other libraries as well. Import NumPy as MP. Import matplotlib.pyplot as PLT. import Seaborn as SNS. So NP is the abbreviation for NumPy, PLT for Matplotlib.pyplot, and SNS for the Seaborn. Let's run this cell. And since no errors showed up, these libraries have been imported in our file, and we can now use them in this file. Pandas is the most popular and important library for data science. It forms the foundation of data science as it allows storing, accessing, cleaning, and processing data. We discussed lists, dictionaries, and tuples in Chapter 1. Those are called data structures as they provide a structure to organize our data. Pandas also provides two types of data structures: series, which is one-dimensional, and data frame, which is two-dimensional. We will discuss each one of them in detail in the third module of this course. NumPy is another popular library for data science, which provides a multi-dimensional data structure called NumPy Arrays, and also provides a lot of high-level built-in functions to be operated on these arrays. We will discuss NumPy Arrays in detail in the upcoming lectures. Since Pandas Data Frames can also be thought of as a 2D arrays, therefore NumPy array functions can also be applied on these data frames. In fact, it is interesting to note that the Pandas is built on top of the NumPy and is also borrows a lot of functions from it. Pandas and NumPy work hand in hand with each other. Pandas handles data organization and processing, while NumPy handles the mathematical computations. As told earlier, Pandas is built on top of NumPy. It allows to access many of the NumPy's functions with less code. However, we still be using NumPy functions frequently. Matplotlib is used for data visualization. It allows us to plot a variety of graphs such as line graphs, bar plots, scatter plots, and etc. The pyplot module inside of the Matplotlib library makes it work like MATLAB, which is a programming language for plotting. We have a dedicated module on data visualization where we can discuss Matplotlib in detail. Seaborn is another powerful data visualization library. It is built on top of Matplotlib and extends its functionality by providing additional types of graphs with fewer syntax. In the next few slides, we'll be looking into NumPy arrays and their built-in functionality. NumPy arrays are a grid of values which can be multi-dimensional. A NumPy array is called n array. NumPy arrays can be created using Python lists. The difference between NumPy arrays and Python lists is that NumPy arrays provide more built-in functionality than Python lists, and also more efficient than Python lists in terms of memory consumption and speed. We can create a NumPy array using the .array function inside the NumPy library. We pass a Python list or a tuple as argument to the .array function, which is then converted into a NumPy array. Let's have a look at how can we create a 1D NumPy array. To create a 1D array, we pass a 1D Python list or tuple as an argument. A 1D list / tuple is a list in which each element is 0D or scalar. These are the lists that we look into in Chapter 1. Let's move to Jupyter Notebook to create a 1D NumPy array using 1D Python list. We start with importing the NumPy library as np. So, import NumPy as np. We create a 1D array and we store the array in a variable called oneArray. oneArray equals np.array 1-2-3-4-5. Print oneArray. We run this cell and you see we get a 1D array. We can check the number of dimensions of a NumPy array using the .ndim attribute. Print oneArray.ndim. We run this cell and we see that one array has only one dimension. To create a 2D array, we pass a 2D list or tuple as an argument to the .array function. A 2D list is a list in which every element is a 1D list. Let's see how we can create a 2D list in NumPy. Let's create a 2D NumPy array using a 2D Python list. Our outmost Python list will contain two lists, each of which will contain 3 elements. 2D array equals np.array 1-2-3 4-5-6. Print 2D array. Let's run this cell and see the output. Here we go. We get a 2D NumPy array as output. Let's use the .ndim attribute to confirm that our array has 2 dimensions. Print 2darray.ndim. We run this cell and it says 2, so our array is indeed a 2D array. A 3D NumPy array can be created using a 3D Python list or tuple. A 3D list is a list in which each element of the outermost list is a 2D list. To create a 3D NumPy array, we will be using a 3D list. Our outermost layer will contain 2D lists, each of which will contain 2 1D lists. Each of these will contain 3 scalars. Let's do it. 3D array equals np.array print 3D array. We run this cell and we get a 3D array. Let's actually confirm this. Print 3D array.ndim. Let's run this cell. And here you go. Our array is 3-dimensional. Ready for a small quiz? How many dimensions does the given list have? Hint: see if the outermost array contains a 2D array or a 1D array. Since the outermost array contains a 2D array, it is a 3D array. So, the correct answer is option C. Indexing a NumPy array is the same as indexing a 1D list. Use square brackets to get element as a particular index. To index a 2D NumPy array, we provide two indices inside the square brackets. First value is the index of the inner 1D array, and second value is the index of the scalar inside the 1D array. Let's practice indexing a 2D array in Jupyter Notebook. Let's go ahead and create a 2D array. 2D array equals np.array 1-2-3-4-5-6. Print 2D array. Let's run this cell. So, we get a 2D array in the output. We want to index the first element of the second array, which is an integer 4. Let's do it step by step. First, we index the second array by providing its index inside the square brackets. Print 2D array 1. We run this cell and we see the 1D array, which is an index, 1 inside the 2D array. Now, to index the first element inside this array, we provide a second index inside the square brackets, which is going to be the index of the element we want. So, we provide the index 0 as it gives us the first element inside the array. Print 2D array 1-0. Let's run this cell to see if we get the desired output or not. And here we go. We do get the desired output. To index a 3D array, we provide 3 indices inside the square brackets. First index is the position of the 2D array inside the outermost array. Second index is the position of the 1D array inside that 2D array. And third index is the position of the scalar inside the 1D array. Let's have a look at a 3D array indexing in Jupyter Notebook. Let's create a 3D array similar to what we created earlier. 3D array equals np.array. Print 3D array. Let's run this cell and we see that we have a 3D array. We will try indexing the first element of the second array of the first array. Let's have a look at the structure of our array. Our outermost array contains 2D arrays. Then each of these 2D arrays contains 1D array. Finally, each one of these 1D arrays contains 3 scalars. Our desired element is at the first position of the second 1D array of the first 2D array. To index this element, we start off by indexing the first 2D array. Print 3D array 0. We run this cell and see that it gives us the first 2D array. Next, we index the second 1D array inside this 2D array. Print 3D array 0-1. We run this cell and get the 1D array that we wanted. Finally, we index the first scalar of this 1D array. Print 3D array 0-1-0. Let's run this cell to see the output. And here we go. It gives you our desired element quiz. Let's test your knowledge. Consider the 3D array x. What will x 0-0-0 return? Our 3D array contains one 2D array, which contains one 1D array, which contains 4 scalars. So, first index 0 will give us the 2D array inside the 3D array. Second index 0 will take us to the 1D array inside of that 2D array. And thus index 0 will give us the first element of the 1D array, which is 1. So, the correct answer is option A.